Welcome back, everyone, to another session on statistics on how to visualize your data in jamovi. These are the objectives of this session. Gonna talk about how to create histograms and density plots in jamovi, how to produce box plots and violin plots in jamovi, how to create bar graphs in jamovi, and finally, I'm going to talk about how to export your plot or graph from Jamovi to a different format. So it's a short session. It's only about data visualization. So at the end of this session, I expect you to be able to meet all of these objectives. Um, it's very important to visualize your data for several reasons. First of all, through visualization of your data, you get to know the distribution of your data, whether there are any extreme values, whether there are any problems in your data or not. Aside from that, if you want to present your data in a session, in a project, or to an audience, it's always good to start with some histograms, with some graphs, because it's the best way to get the gist of your data, to communicate the gist of your data. Also, visualizing your data gives you this opportunity to present your data in a more understandable manner. I don't think that if you want to like uh, present your study or present your results, present your work to someone who is not in your field, I don't think that you could go through all those like statistical concepts. So you need to be able to present your data in a manner that everyone out of your field could understand it. And graphs such as histograms, density plots, box plots, violin plots. Generally speaking, visualizing your data is the best way to do that. Histograms are one of the best tools to present interval data or continuous data. Basically, they take your data and present them in the form of some bins. All the bars you see there, they're kind of called bins. So uh, by looking at a histogram, you can get uh, a lot of information about your data. First of all, you can get to know how your data is spread out. You can get an insight of the distribution of your data. For example, if you look at the histograms here, if you look at histogram C, you could easily see that your data is following a normal distribution because it's a bell-shaped curve. However, if you look at the histogram B, you could easily see that it's a negatively skewed histogram where a lot of data is clustered on the right side of the histogram. On the other side, we have a histogram with a positive skew where the right tail is thicker and longer than the left tail of the distribution. So this is the very first information you can get out of a histogram. So if you want to know whether your distribution, the distribution of a variable is following a normal distribution or not, then you can just create a histogram. Aside from the distribution itself, uh, you can see where the central tendency is. For example, if you look at histogram C, you could easily see that the mean, mode, and median are all in the middle of the x-axis. However, if you look at histograms B and A, definitely mean, mode, and median are placed on different places over the x-axis. So by looking at the histogram, you can definitely see where the central tendency is located. Also, you can get to know the variability in your data. One easy variability measure is range. By looking at the most left-hand side value and most right-hand side value in the x-axis, you could easily see the range of your data. You could easily see how your data is distributed. So histograms are very, very useful. So they're almost always used with continuous data. It's very easy to use them with continuous data. There's also another variant of a histogram, which is called a density plot. You could see the a image at below, the one in blue with the blue bars, and then you see a red line. That's a density curve, that red line. If you want to have a better sense of your distribution, it's better to have a density plot, because a density plot is basically the same exact histogram, but with that density line added to the histogram, so you can easily decide whether your data is normally distributed or is suffering from a positive skew or a negative skew. Now let's see how we could create a histogram or density plot in Jamovi. So let's first import our data. Okay, let's open. So I'll open the same data set we've been working on so far, PWA naming. So here is the data. First, have a look at the data, see everything is okay or not. Yeah, this is the latest photo we've been working on, and then we want to we want to start creating histograms and density plots using this data. So our dependent variable is picture naming latency. We have other continuous variables too, like anxiety level throughout the treatment. We have a comprehension, production, pragmatic test, and also we have education, which is not here. Interval is an ordinal uh, scale variable. So we click on exploration. So far, we've been only working with this exploration tab here. So uh, is the main tab we use for descriptive statistics. We click on descriptives. Yeah, we'll put picture naming latency into the variable one. So uh, these are you see the results box here, and then you'll see some figures showing up here. But we talked about these figures and how to obtain them in another session. But this session, we're going to talk about plots. So I'm going to focus only on plots. So there is this menu here. You just click on it, and then there are different types of plots. I talked about histogram, and I said that histogram is one of the best graphs if you want to present your continuous data. So we click on histogram. So this is what it shows. So, well, if you want to see whether your dependent variable follows the normal distribution or not, see, you just click on density, and it adds it turns into a density plot. It adds a curve, a density curve here, which makes you decide whether it follows a normal distribution or not. Uh, this data actually comes only from 30 people, so that's why we still have like some empty cells here, so we don't have any data here. But we could easily see that uh, the mean of the data is somewhere around here, and then if you want to have an insight in the variability of the data, you could see that it ranges from about 1000 to 1800. And then we kind of have uh, more distribution here rather than here. We only have one or two probably values here and then no value here, few values here. So let's add the density plot again. You could easily see that it's kind of uh, so, not really uh, fully normally distributed, but it's not bad. Um, yeah, it could be a bit negatively skewed because the left tail here is a bit longer than the right tail, so it's not perfectly symmetrical. So yeah, through creating a histogram or a density plot, you can easily uh, detect the distribution of your data very quickly and see where the central tendency is. You can easily see here. One of the mode is somewhere here around 1500, 1450 millisecond. You could have an insight of the range and the variability of the data. Indeed, if we can have a look at skewness, so can easily see that, yeah, I if you don't even need the value here, but if you just look at the histogram here, I told you that it shows a little bit of skewness, and then here you could see the minus point. It's saying that it's a bit skewed. So if you want to decide based on the things I told you in the previous sessions, if you want to decide whether this skewness is problematic in your data or not, you can basically divide this skewness value by the standard error of skewness. And if it's beyond 2, then it's problematic. So we did it last session and it wasn't beyond 2, so it was completely okay. So the skewness here is not problematic. The next thing I'd like to talk about are box plots and violin plots. Box plots are an amazing tool to look at your distribution and your data. Uh, it's one of the best tools for interval or continuous data, again, just like histograms. And it gives you a lot of information, some similar information to what you can get from a histogram. So uh, that's the structure of a box plot, what you could see here. That's a box plot. So a box plot gives you information about the median, this yellow line in the middle is median. And then there is a box around this line, which stands for interquartile range. So we have the interquartile range in the box, and then we have these lines which are called whiskers, and then we have two other lines which uh, kind of are similar to like three standard deviation. If the data is normally distributed, the median and mean stand on the same line. So the extreme lines here stand kind of with three standard deviation below and above the mean. Here, if you multiply the interquartile range by a, uh 1.5 and add it here and here, you kind of get the extreme values. So if by looking at a box plot, you can easily find where the median is, whether your distribution is highly clustered or not, what is the distribution of your data, and you could also see whether uh, you, that data is positively or negatively skewed. And one good property of a box plot is that it will give you information about outliers. So anything which goes beyond these extreme lines, the one here and the one, look at these green dots here. These green dots here, they're kind of outliers because they're beyond a these three standard deviation rule. I mean, if we think that distribution is normal, this kind of fits very well with a standard distribution, which you can see here. And then, yeah, basically with a box plot, you can see where the median is, how well your data is distributed, whether it follows a normal distribution or not, and then you can detect your outliers. Another variant of a box plot is a violin plot. That's a violin plot on the right here is exactly like a box plot, but we just have density added to that. So with a violin plot, see, you can easily look at the tails, see whether the tail on the right side and the tail on the left side uh, are symmetrical or not. You can easily look at the density and see which part of the data is bulkier, where the data is clustered, whether the median and mean are on the same line or not. So it kind of gives you extra information with a density information. So this is basically the structure of a box plot, and this is how we read a box plot. This is how we decode a box plot and a violin plot. So in the next slide, I'm gonna uh, uh, teach you how to do it in jamovi and then how to interpret that using real data. Well, let's see how we can create a box plot or a violin plot in Jamovi. So we kind of open our data. We already have the data, so this is the same data set. We go to exploration, again, descriptives. We put picture naming latency in the variable, so we want to look at picture naming latency using a box plot or violin plot. So we go to the plots menu, click on it. We have so many different types of plots and graphs. So we click on box plot. So this is the box plot for picture naming latency. So they the solid line here, the solid black line here, stands for median, which is 1452. Here also 1452. And then we have the minimum and maximum. You see, the minimum and maximum correspond with the minimum and maximum we have in the descriptive statistics table. So this almost this box here stands for the interquartile range. So based on what I described in the previous slide, we have no outliers here. So there are no outliers that go beyond these lines. Otherwise, we should have seen things here, like dots here. So we have no dots here. So if you want a violin plot, you just click on violin plot and it'll show you the density of this plot. So based on the density information, we could easily see that the data is mainly clustered in the center, but we could easily see that the left tail is kind of longer than the right tail. So there could be some outliers in the left tail. What do I mean by the left tail? You can easily click on histogram. So, and density. See, this is the left tail here. So this left tail here corresponds with this part of the a box plot. So we might have some outliers here. So the data looks a little bit like with a little bit of negative skewedness, which you could see here. And you could also see here in a density plot or histogram. So uh, as I told you, it's very useful. Box plot is very useful because you could see where the median stands, where the interquartile range stands, how clustered, how spread out the distribution is, whether it's skewed or not, and most importantly, whether you have any outliers in your data or not. So once you look at picture naming latency, it seems that you don't have any outliers. But uh, sometimes you have groups in your data, like you have categorical data, and you want to look at the distribution of data across the groups. For example, we have aphasia type as a categorical variable. So we have people with fluent aphasia and people with non-fluent aphasia. And we want to look at the distribution of picture naming across these two groups. So you can basically click on aphasia type and put it in the split file. Let's look at the box plot. Wow. Now you could easily see that in the non-fluent a, data set, we have at least one outlier because there is one data point here which is staying out of this whisker line. And you could easily see that the median of the non-fluent group stands higher than the fluent group. uh, it seems that the data in the non-fluent group is very much clustered in the center. The data in the fluent group is more distributed. So, and then in the fluent group, we have no outliers. So you can add a violin plot. You could also see the same pattern. Data is highly clustered in the middle around the interquartile range in the non-fluent group, but when it comes to the fluent group, the data is pretty much a spread out uh, across the individual. So let's look at a histogram. So this is the histogram of each group. So we have the fluent group. Look, the fluent group is pretty much distributed, and then you can also see here that is highly distributed. But look at the non-fluent one. The non-fluent one, the data is highly clustered here. You can also see it here. And also, we have a longer tail on the left, which you could see it here. So the outlier, this one, could be this. These points here could be the outlier. So in another video, I'll tell you how to find the outlier in our database, but this is pretty much what we wanted. So you click on box plot. That's the box plot. If you want the data to be shown on the box plot, you can easily do this. You see? Now these are the data points. So we have two outliers in the non-fluent group, but in the fluent group, there is one just right on the border and one here right on the border. We have three more in the non-fluent group right on the border. But yeah, if you want to see your data with the box plots, you can click on the data option here, and then you can see your data here too. And then if you also want to see the mean, with the median, you can click on the mean and then you'll see the mean. So you could see that the mean in the fluent group is very much on the same line with the median. So this black box is the mean. But when it comes to the non-fluent group, the mean is lower than the median. Why? Because we just showed it here that because the data in the non-fluent group is negatively skewed. So there are some outliers here, down here in the beta, which are kind of pulling the mean towards themselves. So that's why the mean is lower than the median, because these outliers are decreasing the mean. Yeah, that's all I think you need to know. You can play with the data. You can add like other um, groups in the data and just try to look at them and try to interpret the data. And if you have any questions, please let me know. I just told you that one way to detect outliers and extreme values in your data is through box plots. So let's just demonstrate it here in this video. So we have our data here. Let's look at picture naming latency again. So fascia type and box plot. So we could see that if we click on box plot and then we'll project the data on the box plot, we'll see that we've got kind of one or two a, a outliers in the non-fluent data. So how to find these outliers in our database is pretty simple. Once you find it, it's kind of like about 1100 millisecond. So we can just um, go to uh, data. We click on picture naming. So we want to create a filter. That filter allows us to see data points below a certain value. So, for example, I want jamovi to filter out data points below 1100. So we'll click on filter, and here we need to put the name of the variable, which is picture naming latency. And I'm telling Jamovi that filter out values uh, below 1100. And you basically click on it. And then you'll see here, you easily see here that uh, participant number 5 is excluded from analysis, and his or her reaction time is 1047, which is below 1100. And then we have participant number 16 with a reaction time of 1043, which is below 1100. And the rest of them are fine. So, and then the box plots here are accordingly updated. So we have now, if you look at the box plots, we have a we have no outliers. So there was one outlier in the fluent group and there was one outlier in the non-fluent group. Both of them are removed from the box plot projection, and you can't see any outliers here. So any data point is kind of within these lines. But if again you want to see the original one, you just need to delete it, click on the box plot and just select it again, and then you'll see the data points again here. The outliers kind of are popped out again here. So uh, that's how you can detect an outlier, and then through creating a filter in your data, you can go and see which data points are corresponding to these uh, dots here, the outliers. The last type of graph I'd like to talk about is the bar graph. So far I've talked about graphs or plots you could use with a interval or continuous data. But then we also need graphs to present categorical data, nominal data, or sometimes ordinal data. Bar graphs are one of the best solutions to present nominal data and ordinal data. Basically, you have like just like a histogram, you have bars or bins. But the difference between a bar graph and a histogram is that in a bar graph, there is some white space between the bars, which makes it different from a histogram. So we use the bar graph only with a nominal data, and if we want, we could also use it with ordinal data. In the next slide, I'll show you guys how to create a bar graph in Jamovi. So we have the data here. We want to create a bar graph, and we want to create a bar graph for our categorical variables here. So we go to descriptives. We put, for example, aphasia type here. We want to see like how many people we have within in each of the groups in this variable. So we go here to the plots, we click on plots, and then we have the bar plot here. So you could see that in this variable we have two levels, fluent and non-fluent. So our participants, our population consists of two groups, fluent group and non-fluent group. And within each group we have 15 people. So you can easily create different types of bar plots for other categorical variables, such as treatment type, and see again we have three treatments and we have 10 people, exactly 10 people within each treatment. And gender, we have 30 people, 15 female, 15 male. So you can also add aphasia type here, and you can get pretty good bar plots such as this, where you can look at the distribution or look at the frequency of two variables together, such as gender and aphasia type. So you could see that in the female group, we have like eight people with aphasia and seven people with non-fluent aphasia, while in the male group is completely the opposite. We have eight people with non-fluent aphasia and seven people with fluent aphasia. So the bar plot is very, very useful if you want to uh, give a short and brief summary of a categorical variable, and then it's not only it's not limited to just one categorical variable. Basically, you can add more categorical variables and see how the frequency is across all of these variables. After we created a bar plot such as this, and if we want to save it in a format or export it to a different format and present it somewhere else, it's very easy. You just right click on the plot here, and then you can copy it and paste it on a Word document, but there is also export option. So uh, there are different formats: PDF, PNG, SVG, EPS. PDF and PNG are the most useful ones. So I select PNG, and the name of the file could be uh, like aphasia plus gender, for example. And then I just export it. And then uh, I'll see, yeah, I have it here. Aphasia, gender, you can easily see that. There is a PNG file saved here in my directory. I click on it, and yeah, that's exactly the same plot I created in Jamovi. Now I have it here. I can just save it here, and then if I want to use it later on, I can easily retrieve it from here and integrate it into a PowerPoint presentation or Word document. Now we come to the end of this session. So before we end this session, I'd like to check with you guys whether you have learned the following objectives or not. At the end of this session, you should be able to create histograms and density plots in Jamovi and interpret them, uh, read between the lines, look at the histograms, see whether your distribution is okay or not, or is suffering from any uh, problems. You should be able to produce box plots and violin plots in Jamovi, and then you should be able to interpret these type of plots too. You should be able to detect the outliers based on these plots and go and find the outliers in your data set. You should be able to create bar graphs if you have any categorical variables in your data. You should be able to create bar graphs. And then finally, after all of this, after you have created a lot of plots and graphs, you should be able to export your plot or graph to the format you like. I hope that you liked this session too. It was a very practical session. It's very important to be able to create plots and graphs. It's very important in data science to be able to visualize your data in the best manner. It's indeed a skill. So I hope that you learned something from this session, and please stay in touch. Write to me if you have any questions or suggestions. I'll be happy to hear from you. And yeah, see you next session. Have a good time. Bye bye.